Hello, this is the Blonde Analyst, and today we are going to be going over joins. As you can see here, we have two very simple columns representing different tables, and we're going to be going over what are joins and how are they useful. Now, joins are just combining two different rows or tables as such and making one out of that. Joins could be used in things from Microsoft Power BI to PostgreSQL to other different languages. There are 6 different types of joins, 3 outer and 3 inner. We have left outer, right outer, full outer, inner, left anti-inner, right anti-inner. Now, with these different joins types, we will go over each one individually and go over how they will look like. So as you can see on our first table, we just have 1, 2, 3, A, B, C. On our right table, we have 2, 4, 6, B, D, F. The first ones that we'll go over are the outer joins. Now, the left outer join is all from the first table matching the second table. So let's put this in some sort of Venn diagram so we could really understand what's going on here. Now, with the left outer join, as we said before, we're going to be going over all from the first table matching the second one as well. So that just means this left circle, all of it. So that will be this and this. So our new table with left outer would be 1, 2, 3, A, B, C. Very simple. Right outer is the right circle. So that would look like 2, 4, 6, B, D, F. We also have a full outer. That is all of the rows from both tables. So that would be 1, 2, 3, 4, 6, A, B, C, D, F. We have inner only, and that is just the ones that are matching from both. So that would be 2 and B. We also have left anti. So that is only the rows in table 1. So that is exclusively table 1, not the similarities in table 2. So that would be 1, 3, A, C. And right anti is the opposite. So that would be table 2. So that would be 4, 6, D, F. Now, when we are writing down these joins, it is in the order that you put them in. So if we were to put table 1 left outer, table 2, table 1 is on the left side. So that would be the left outer. If we do table 2 left outer, table 1, then table 2 is on the left side. So the order does matter. So just in case I went a little too quick, I ended up writing down all of these tables and I labeled them on the top just so you could check over and make sure that you are able to understand everything with the left outer join, right outer join, and all of the inner joins as well. Now let's try to get a little bit more of a complicated table and being able to show a more real example of this and see how we could interpret joins into our PostgreSQL. So we have 2 tables here. One is named Sea Lions and one is named Migrations. So let's go on with one of our tables named Sea Lions, and these are just going to be 3 separate sea lions with very unoriginal names of A, S, and J, with their IDs on the side being 101, 117, and 119. Now, the reason that they have IDs is just in case we end up coming across a different C line with the same name, and we are just going to be recording these sea lions travels. So some may be traveling a certain amount of time over a certain distance, and we just want to record to see how far they are traveling, which leads us on to our next table, which is the migrations table. Now the migrations table has the IDs from before and also some other IDs from different maybe data sets or other sea lines that we may have been recording before. It also has the distance that they've traveled over how many days they have traveled. Now let's try and select all and join these two tables together, and let's see what happens. We seem to be getting an error, and it says syntax error at end of input. The reason for this is actually because with this join function, we also need to specify where we want to join the table. What are going to be the similar columns that we are going to be starting to filter things out from? So what two columns do these tables have in common? As we can see, it has the same ID column. So we're going to be filtering it out by doing something called join migrations on, and we're going to be putting these two columns from these two specific tables. So we're going to be doing migrations dot ID equals clients dot ID. This dot just specifies what specific column we're going to be looking at. So in this, it just means in the migrations, in the ID column, that is going to be the same as the clients dot ID column. So what we should be getting out is, oops, there we go. So we have a table with the ID, the name, the ID of the same ID, the distance, and the days. As you can see, we have a repeat of the ID column. So this is just a general join. Let's say we want to go over some different types of joins. So now we'll go over some of the outer joins. So we have the left outer join, which is the same table. We have the right outer join, which now we can see some null values here. And this is because these IDs were not mentioned in the clients table, but they have to be mentioned in the right outer join because of the fact that in this specific query, on the right side we have the clients. And since we have the clients on the right, we need to include the entire right table, which is in this case clients, even if they do not have an ID or a name. Now, because when we had left, we have migrations on the left side, we do not include these null values because they're not in our table. Now, let's say we do a full outer join. That will end up being the same thing just because of the fact that this is all of our values. So now we'll use a Venn diagram to really understand sets. In table 1 we have value 1, table 2 we have value 2, and the common value will be value 3. For table 1 intersect, table 2 will be value 3 because that is where they both intersect. table 1 union table 2 will be values 1, 2, and 3 because we are combining all of the values. Table 1 except table 2 will just give us table 1, and table 2 except table 1 will just give us value 2. And honestly speaking, that is all we have for joins and sets. Thank you guys all for watching. I wish you guys all the best of luck in learning PostgreSQL. Thank you.